How familiar are you with the concept of AI adversarial attacks? In the world of artificial intelligence, this term refers to the deliberate exploitation of AI systems with the intent to cause malfunction or misuse. These attacks pose significant risks, with potential implications spanning across various sectors such as security, finance, healthcare, and autonomous systems. Imagine a compromised AI system being used to launch attacks on other systems, manipulate financial markets, or even provide incorrect medical diagnoses. The consequences could be dire. Hence, understanding these threats and exploring ways to mitigate them is of paramount importance. Researchers and security experts are tirelessly working on developing techniques to defend against these attacks. But it's also crucial for us to stay informed and vigilant. The field is rapidly evolving, with new attack techniques and defense mechanisms emerging all the time. So, buckle up and prepare for a deep dive. Now let's dive into the different types of AI adversarial attacks. Imagine you're training an AI model and suddenly it starts making incorrect predictions. You might be facing an injection attack. In the world of artificial intelligence, this is a common and potentially harmful scenario. Injection attacks are a type of AI adversarial attack where malicious data is introduced into the AI model during its training phase. One of the common methods of injection attacks is data poisoning. This involves adding malicious data to the training set. The AI model, unaware of the tainted data, learns from this and eventually starts making incorrect predictions. It's like teaching a child incorrect information and then expecting them to perform well on a test. Another method is label flipping. This is where the labels of the data are intentionally changed to mislead the model. For example, imagine the AI is being trained to identify images of cats and dogs. In a label flipping attack, the labels of some images might be swapped, causing the AI to learn that dogs are cats, and vice versa. The consequences of these attacks can be quite serious. They could lead to AI models making incorrect decisions, learning unwanted biases, or being used to propagate misinformation. So we can see that injection attacks are a significant threat to the integrity of AI models. They can lead an AI model astray, subtly altering its behavior in ways that can have far-reaching consequences. But remember, they're not the only way to compromise an AI. What if the AI model you trust is compromised after deployment? Welcome to the world of infection attacks. Infection attacks are a crafty form of AI adversarial attacks. They involve sneaking into a fully trained and deployed AI model, like a stealthy burglar in the night. The attackers aim to take control of the model's outputs. This is often done through techniques like model extraction or poisoning. So, picture this. Your AI model has been trained to perfection. It's out there in the world, making predictions, providing insights, doing its job. But then an attacker compromises it. They could extract the model, essentially making a copy of it, which they can then manipulate at will. Or they could poison the model, subtly tweaking its parameters so that it starts to behave in ways it was never intended to. The risks associated with infection attacks are serious. A compromised model can cause significant harm. It could start making incorrect predictions, leading to financial loss or reputational damage. Worse, it could be used to launch further attacks, spreading the infection like a digital epidemic. Furthermore, the attacker now has control over the model's outputs. They can make it say whatever they want it to say. In a world increasingly reliant on AI for decision-making, the implications of this are far-reaching and potentially devastating. So, infection attacks can turn your trusted AI model into a puppet. But there's more to learn about AI adversarial attacks. Do you know how an AI model can be tricked into making wrong decisions? Enter evasion attacks. Evasion attacks are a cunning breed of adversarial attacks, with a goal to hoodwink AI models into making errors. They accomplish this by creating inputs that the model misinterprets, causing it to make incorrect decisions. Think of it as a master of disguise presenting a false identity to the AI model. But how does this work? Imagine a chameleon in a forest, perfectly blending with its surroundings, almost invisible to predators. In the digital realm, evasion attacks use a similar strategy, deploying adversarial examples. These are carefully crafted inputs that seem normal to us humans, but completely bamboozle the AI model. Adversarial examples are like optical illusions for AI. They could be images, text, or audio inputs that have been subtly tweaked to mislead the model. To the human eye, these tweaks are often undetectable, but they cause the AI model to misclassify the input, leading to incorrect decisions. Consider a self-driving car, misidentifying a stop sign as a speed limit sign because of an evasion attack, or a voice recognition system misunderstanding a command due to a slight distortion in the audio input. These are the kind of scenarios that can arise from evasion attacks. So evasion attacks are like the digital world's chameleons, blending into the data landscape to trick AI models into making false decisions. Evasion attacks can make your AI model see things that aren't there. But the list of AI adversarial attacks doesn't end here. How about stealing sensitive information from an AI model or making it unavailable? Meet extraction and DOS attacks. Extraction attacks are like stealthy thieves in the night. They aim to pilfer valuable data from an AI model, such as its training data or internal parameters. This can be done through techniques like reverse engineering or side channel attacks. Imagine this. You've spent countless hours training your AI model, feeding it the best quality data, and fine-tuning its parameters. Then, an extraction attack happens. It's like someone just walked into your vault and walked out with all your precious assets. The consequences can be serious, from the loss of proprietary information to a breach of user privacy. But that's not all. Let's move on to the menacing DOS attacks, short for denial of service. Their goal isn't to steal, but to disrupt or disable. They are the digital equivalent of a roadblock, making your AI model unavailable or unusable. This can be done through techniques like resource exhaustion attacks, where the model is overwhelmed with inputs until it can't function, or flooding the model with so much data that it simply can't keep up. So, imagine trying to drink from a fire hose. That's what a DOS attack is like for your AI model. The effects of both extraction and DOS attacks can ripple across various domains. In security, compromised AI models can launch attacks on other systems, steal sensitive information, or disrupt critical infrastructure. In finance, they can be used to manipulate markets or defraud individuals and businesses. In healthcare, manipulated AI models could provide incorrect or even harmful medical advice. And in autonomous systems, a disrupted or disabled AI could lead to accidents or harm. Extraction and DOS attacks can have serious consequences, but remember there are ways to defend against these threats. So, as we navigate the exciting yet challenging landscape of artificial intelligence, let's ensure we're not just focused on building smarter AI, but also more secure AI. Because after all, the best offense is a good defense. Now that you know the threats, how can you defend your AI models against these attacks? Well, fear not. Researchers and security experts worldwide are working tirelessly to develop strategies to mitigate these AI adversarial attacks. One such promising approach is adversarial training. It involves exposing AI models to adversarial examples during their training phase. Think of it like a sparring match in boxing. The more you spar, the better you become at defending yourself. Similarly, the more an AI model is exposed to these tricky inputs, the more robust it becomes at handling them. Another strategy is defensive detection. This involves developing smart algorithms that can detect and flag suspicious inputs or anomalous behavior in the model. It's like having a watchdog that barks at the sight of an intruder. If something seems off, the algorithm raises a flag, alerting us to potential threats. Then we have formal verification. Now, this may sound fancy, but it's all about mathematically proving that an AI model is safe and secure under certain conditions. Remember, in the world of AI, it's not just about intuition. It's about concrete, mathematical proof. When we can verify a model's safety formally, we're one step closer to ensuring its robustness against adversarial attacks. Last but certainly not least, we have explainable AI. This is all about making AI models more transparent and understandable. With explainable AI, we can better identify and address vulnerabilities in the model. Imagine being able to peek inside the black box of an AI model, understanding its workings and spotting any weaknesses. That's what explainable AI aims to achieve. As we navigate the ever-evolving landscape of AI adversarial attacks, it's crucial to stay informed about the latest developments in the field. New attack techniques and defense mechanisms are emerging all the time. By keeping up to date, we can be prepared and proactive in defending our AI models. By understanding and implementing these defense strategies, you can help protect your AI models from adversarial attacks. AI adversarial attacks pose significant threats, but they are not undefeatable. From the subtle manipulation of injection and poisoning attacks, the stealthy compromise of infection and evasion attacks, to the outright disruption of extraction and DOS attacks, these challenges are real. But with mindful strategies like adversarial training, defensive detection, formal verification, and explainable AI, we can bolster our defenses. This evolving landscape demands our constant vigilance and proactive measures. Stay informed, stay alert, and remember, the best defense is a good offense.